We're recording. So this is intermediate algebra, October 7th. Only Mariana is present, but she's waving. Nobody can see her. So today we're going to do chapter 10.8, a super interesting chapter. And according to the syllabus, actually this would conclude our study of chapter 10. And next week we're going to do review on Monday and test on Wednesday. So we can do the test here in person or at home. Last time we did it, what did you do? Yeah, so I'm assuming everybody is doing it at home. It's easier. Yeah. Okay. So next Wednesday would be the.
Is chapter 11 better?
Yeah, kind of. Because I kind of modified chapter 11. I think the other ones are easy. This one was hard. Okay.
Thank you, Jesus.
Although this right now, this chapter is easy. This subchapter.
What?
I think it is this section right now. We're going to do today.
Oh,
okay. What is called is about complex numbers. So do you know, Mariana, that not every number is real?
Say that again?
Do you know that not every number is real?
Not every number is real?
Yeah.
Oh.
She didn't know. She didn't know. Yeah. So here are the numbers. So you can have. Where is my pen? Let's get the annotate. Okay. So you can have. Where are the numbers? Okay. I guess I don't know if this is really helpful. But this is not very helpful, so we're going back to the beginning here, okay, the previous one. Okay. So we have, you know how we have numbers like 1, 2, 3. These are the counting numbers. Then you have like 0, 1, 2, 3. These are the whole numbers and so on. Then you have minus, infinity, minus 1, 0, 1, 2, 3. These are the integers. This is called integers. What are you doing? Okay. She's separating the cover for her gum. I don't know why. I'm just wondering. Okay. So integers. And then we have rational numbers like 3 over 2, 8 over 5. All the numbers which can be expressed as ratios. Then you can have all the irrational numbers, which are like square root of 2. For example, some things which keep going forever, pi, and so on. Okay. So then, these are all different kind of numbers. So these are all real numbers, though. So all those, they're real. They're real numbers. There are some other numbers which are not very real. They exist, they're pretty useful. They are numbers, but they're called imaginary numbers. So they're real, imaginary, and imaginary actually just a little part of so-called complex numbers. So the imaginary numbers, who are they?
So would it be like 1 or just x? The imaginary number would be 1x?
No, the imaginary numbers is the definition. To get imaginary number, this is the definition. Square root of minus 1 equals I. This is the definition of imaginary number. It's a number which doesn't really obey the rules we have established. I mean, it obeys the rules, but like, I don't know, for example, it doesn't exist like something is not one of those, right? Because square root of minus 1. So to find out this, you're like, let's say if you have square root of 4, what is square root of 4? 2. So because 2 times 2 is 4. So when you're looking at the square root, you're asking yourselves, which number multiplied by itself would give you 4, right? And the number was 2. But when you look at square root of minus 1, you're like, which number multiplied by itself, x times x, well, this number will give you minus 1. Is it minus 1? No, we cannot, right? Because if you do minus 1 times minus 1 is positive 1, right? If you do positive 1, 1 times 1 is 1. So this is not a number we know how to deal with.
Okay.
So that's why we're defining it as imaginary number.
Would it be also like -7? Would that be?
Yeah, -7 also square root of -7.
Yeah.
So,
Okay, I see that.
so we don't know how to deal with square root of a negative number. So we're going to make a special definition for it. Next page. So here. Don't worry, it says complex number. I'll explain this in a second. For now, just think of this square root of 9 of 1 is imaginary number.
Oh.
The imaginary part of a number. Okay, so this is the imaginary.
Okay.
So square root of -1 is I. And if you square this, right, both sides, you're going to get I squared equals -1. These are the two important two definitions you need to remember from this class. Let's see if somebody joined. Nobody joined. Okay. So these are definitions. What you're going to do with this -1, for example, let's say you have square root of -8, right? So because of this negative, this is not going to be a real number. So what you're going to do, you're going to split this number, this expression into square root of -1 times 8, right? You can make it like that. This is times and this is minus, right?
Mm-hmm.
And then you can split the square root. If you remember, you can split the square root, right? See? And then I need to keep going under it. Square root of -1 was I. This is I. So then you're going to have I square root of 8. So right, so let me highlight it with some weird color. So technically, square root of -8 equals I square root of 8. So this is imaginary number. You can also simplify 8 like square root of 8 is 2 square root of 2, right? And then you have the I. You always need to simplify the square roots. But for now, my goal is just to show that this imaginary number.
Okay.
Yeah. Okay. So then, what is a complex number? So any number can be actually written as a complex number. Complex number is a complex number. It's a number which, like, it's on top. Like, what is it?
The denominator?
No, it's like terminology. Like we're the human race, right? This is our who we are. No, yeah, who we are, like, is the outside definition. We're a race, but then everybody's individual inside, right? So somehow the complex number is not this is all the numbers, but then everybody inside is different. Okay. Different. So for example, this means that every number can be written as A plus IB. So what does this mean? Let me see if it's in the next page. No. Okay. Previous page? No. Okay. So what does this mean? Let's say, for example, we have the number 3 plus, what did, again, I got the wrong pen. Hold on. Okay. This was the PowerPoint pen. Okay, don't want this. So we want this. Hold on. A plus IB was the number. Oh, now it's blue. Okay. Imagine you have the number 3 plus 2I. Right. So this number is a complex number because it has two parts. The first part is a real part. 3 is called the real part of the number, and 2 is called the imaginary part of the number. See? Yeah.
So the first part is
the real part. Yeah, it's actually, this complex number is one number with two parts. The first part is the real part of the number, and the second part is the imaginary part of the number.
And together they're a complex number.
Yeah.
Okay.
So it's like in real life, everybody, is rational person sometimes, but sometimes it's irrational. You know, inside of you, you have two different people in a way, or whatever. This doesn't sound good, but everybody has a good side and a bad side. Let's say, no, everybody has a real side and imaginary side.
Yeah.
I think of this way. Okay. So, so then the reason the complex numbers are above everything, because if I want to write the number 3, just the number 3, then the number 3 would be 3 plus 0i, right? The imaginary part would be just 0 for the number 3, right? This is a real number, so I can write every real number as an imaginary number, right? Because just I need to set the second part to 0.
Yeah. So any number can be.
Yeah, 5.5 plus 0i is still imaginary. I mean, it's still complex number, but this is the real number, you know, 5.5. Okay. In the same way, if I want to just work at the imaginary part of the number, I can write, let's put it on this side, 0 plus.
So technically, anything I is imaginary.
Yeah, and the other part is the real part.
Okay.
But the whole thing is a complex number, which is,
right.
You know. So if I just want to start the imaginary number, yeah, it's 3. And there is something you don't really need to know, but it might be helpful. How do you represent the imaginary numbers? So if you have real numbers there on the number line, right?
Yes.
Number line. So the number 3 is somewhere here, right? This is 3. But if you have imaginary number where they are actually on the plane. So this would be the real part of the number, and this would be the imaginary part of the number, right? On the y.
Okay.
So if I want to write this number 3 plus 2i, you see this number, right? I want to write this. How is it going to look? I'm going to have 1, 2, 3 on the real part.
Where are you?
I'm taking this number,
okay.
and I'm going to write it on the graph right here. You see, okay. 1. So this is 3 on the real part. So the real part is 3, and the imaginary part is 2. See right there, 2. And this is 3. So my number is actually going to be right here. This is the, I see this thing?
Yeah.
This actually represents the number 3 plus 2i. It's right here. Right. There are these numbers in the plane. Okay. And they actually, sometimes, you know, they have length, but for now we just think of a dot. Right. This is how I represent. They're kind of different, you know, they're in space. But you don't need to really use this. I'm just giving you an idea how different they are. Okay. For you, the important part is if you have square root of 1, which doesn't make sense in the real world, you're going to make this to be I, imaginary number. Deal with it. Okay. Moving on.
Very interesting.
It is interesting. Okay. Next one. Come on, I want to go on the next page. Get this, erase this, take this, move on to the next page. Okay, I'm here, it's next page. So here, Mariana, here is think about. You keep texting, stop texting.
I don't text.
What do you do? What do you do? Then what do you do on the phone?
I check.
What do you check? The weather? Okay. So here, look what it says. Express in terms of I. See, this is what you need to do. And I'm not hiding you're going to look through the process. No, we'll do it ourselves. So what you need to do, you need to, this minus, you need to take care of the negative inside, right? So we're going to split this into square root of -1 times square root of 9, all right? And then,
3.
yes, so, and the square root of -1 is I, so this would be 3i.
Oh.
See how nice? Yeah. Okay, let's do the next one.
Wait, 3i?
Yeah.
Okay.
So now let's do the next one. So the next one, you see this minus, the first minus is just minus. We don't worry about it. It's just a minus floating in space. It's fine. But what we need to do, we need to check the, you know, this minus inside the square root is what we don't like. So we don't like this. So we're going to make this into square root of -1. And then the rest is square root of 48.
Is the times square root of 48?
Yeah. The times. I just
Okay.
times. Okay. So now the first thing is I, right? So this would be I square root of 48. Right. Now we need to simplify 48, square root of 48.
Turn it to the negative.
Oh, you're so smart. Here you go. It's right there. See, Mariana is paying attention. Good.
Not texting anymore.
No. Okay, so then the minus and the I stay, but 48 is 3 times 16. We kind of learn it from experience. And I know what square root of 16 is, but so I can split this into 3 times square root of 16. And this would be, because this is 4 minus, I guess let's do the I first. So I, then 4 times square root of 3. Okay. You can put the I wherever you want. To make it look better, I think it looks better if it's minus 4i square root of 3. But really, the right way to do it is minus 4 square root of 3i. The problem is you don't want I to be under your radical, so you need to make sure your radical like has an ending right there. Okay. But you can arrange it any way you want.
As long as it has all those numbers in it.
Yeah. Okay. So this was the easy part. So continuing here. Next. Imaginary numbers. We talk about this. The B part is the imaginary. Okay. Complex number. This is the general form. So complex number looks like A plus BI. Right. This is what I explained already. Right here. Real part and imaginary part. So, I know to have a complex number, you can have those zeros too. I said that A could be 0, B could be 0, right? Next. So here is the whole picture where you can try to see that the complex numbers they're above O, like the main category. From them you can split into 2 different smaller categories.
Kind of like the colors, the primary colors and the secondary colors.
I don't know. Kinda, yes, but then this means that the complex numbers are like all the colors at the same time, and then you split them into what they're made of, because it kind of encompasses all. So they're real numbers, not real numbers, then the rational, irrational, complex, imaginary. Don't worry about this. We don't need it really to apply. Okay. So they follow all the laws, how to, everything is the same kind. Okay, so let's add or subtract. It's not bad at all. So to add them, they're like, again, adding like terms. You're going to be adding, let's make it red. If you do the first one, A, right?
Oh,
you're going to add the 3 and the 7, yeah, and the 2 and that's it. When you subtract, though, pay attention that you see this minus, you have to distribute it for each one.
Oh.
So yeah, so this would be 10 minus 2i minus 9 minus I, right? Because the minus gets distributed. Okay. And so then we have 10 minus, then you collect the like terms. So we have 10 minus 9, which is 1. And then minus 2i minus I is minus 3i. Here you go.
Man, why couldn't all the problems be as easy as this?
Well, this is just a prequel nowadays. Now we're going to get to multiplication, but let's see. So we know how to do this. Okay, so it's another example. When you have this, so what you have is square root of negative, right? You might think that, oh wait, why don't I just do this? All right. But you cannot do this because this would be positive, right? You cannot do this because when you started, those were 2 imaginary numbers, so they cannot turn into real numbers like that.
So, in chapter 10 point something,
This 10 point
would have been no solution, right?
Yeah, the previous, yeah. There'll be like no real solution.
Yeah.
We said no real solution.
Yeah.
But now there are solutions. It's not real, but now we know how to deal with them. Okay, so then, so split, each one make it into I. Square root of minus 1.
My ear hurts.
Oh, why? So then h1 is I, see I and I. Then I times I is I squared. So now it comes the beauty of it that, remember the two things to remember? One of the
Also,
things,
you still times 6 times 5.
yeah, you do, but after you get rid of the minuses.
Wait, where did the 1 come from?
So this is what I'm saying. So remember I squared. You see, right now we're right here. See? So the two things you had to remember from memorize from this chapter was square root of minus 1 equals I. And the other one was when you square this, I'll just write it without squaring it here. I squared equals minus 1.
Oh, okay.
Technically, it's only one thing you need to memorize, the first, and the second one comes from the first, but you have to remember it so you don't think about it. So I squared is minus 1. So instead of I squared, you actually wrote minus 1 right there.
Okay.
So this is very powerful.
Leave it as I squared?
No, you need to, you have to make it 1.
Right?
No, yeah, you need to make it into, okay. So this is saying, you know, you cannot multiply them and get rid of the negative, right? Yeah. So, multiply. We do this ourselves. Let's start with the first one. You try. So what are you going to get? Did you do the first one?
Is it negative square root of 20?
The thing is, you need to simplify the square root of 20 though. You write is negative on the outside I square, but square root of 20 is 4 times 5, right? You need to get the 4 out.
Oh.
You need to always simplify the radicals. That's why we learned in the previous chapters.
But we didn't do that with the 6.
We did.
On the first.
We couldn't to get the 6 out, could we?
Well,
it was 6 times 5, but you cannot. 30 is nothing you can. 13, 6 times 5. There is nothing you can take out. You cannot simplify square root of 30. Let's do 6. It's okay. You see. Okay, so you have to simplify it as much as you can. Okay. So to the next one. The next one is just multiply. All right. So just distribute. Think. Distribute and see what would happen. Man, I used to spend so much energy writing on the board. Now I'm like lazy. Need to exercise more. Because it's like now I have sedimentary style of teaching because I'm sitting in front of the computer.
Wait, you don't do anything else?
I mean, I do anything at home. I'm trying to
no,
work.
no, I mean here.
Oh, here, yeah. So multiply, yeah.
I plus 6 I squared.
Yeah, but you need to make the I squared into negative 1. So it's going to be minus 6 technically. And there, yeah, there is one thing. They'll mention it. They're going to mention it later. But the good rules, like many times when they ask you to write the problem, they're saying they're asking you to write the problem in the form A plus BI, right? So they want you to arrange to put the real part first and the imaginary second. They didn't ask you here, but they'll ask you later. So just make it like minus 6 plus 10i.
Oh,
you want to have it in the form A plus BI. No, the real part first, the imaginary next. Okay. Next one, C. If you can multiply the C.
So you just distribute on this one?
Yeah. Distribute and see if you can. In any I squared, you need to turn into I, into minus 1. and then add like terms to. And I'm writing the steps kind of.
So is it going to be plus 9 because it was a negative 1 and it was minus?
What is in 9?
So 6. Oh, wait, what did I do?
It's minus 6i plus 4. Maybe, yeah, minus 6i
Minus 6i.
plus 4i. Then we
Plus
have
4.
plus 4i. This is minus 2i. All right. If you then you need to add the like terms, minus 6i and 4i.
Where'd you get 2i?
Because minus 6 and 4 is 2 negative. See, it's like mushrooms. Minus 6 like term. Minus 6 i's and 4 i's. Doesn't this make minus 2?
Where'd you get the 4i?
From this
Oh,
part.
that's an I, not a 1.
Where is C and 1?
I'll start over again.
Okay, minus 2 i's right here. And then the I square becomes minus 1, which I can't.
6i plus 4i. There it is.
Okay, yeah.
Minus 3i squared.
But to continue.
So
Right.
now there's 3.
Where is it? The 3. So we have 8. I'm right here. We have 8. You have the minus 2i, and then you have minus 3i squared. But the I squared became a minus 1. So the whole thing is going to turn into plus 3. Right. The last 3, you see the minus 3 I squared? The I squared is minus 1. So it's going to be minus 3 times minus 1. See?
Minus 3
This minus 1.
minus 1, which is just 3.
3, yeah. So this will become plus 3. And then you can add the 8 and the 3. So it's going to be 11 minus 2i. This is the answer. Right there. Okay. It is easy. It's long, it seems long, but it's actually easy. You need to remember I squared is minus 1. So wherever you see I squared, it's minus 1. All right. Right. This is part of this chapter. Yeah. Let's go to the next page. Here you see how we did it. Okay. This is the fun part. Hold on. Before we do the fun part, what else do we have to do? Conjugate. Oh. Okay. Okay. So we might not finish the whole thing. Okay, here. So you got the idea, right? You just have to practice those. Distribute. Okay. So the next thing to do, it's powers of I. This is really cool. Hold on, I'll just write one. We'll do it ourselves.
Powers of I?
Yeah, this is really fun thing to do. It's more like a game.
Sure.
Okay. So, for example, we're just taking a random number. Oh,
My back go away.
why is your back hurting?
I think I lifted some things.
Oh, yeah. Yeah, this is probably to know the rules for heavy lifting. Right?
Well, I didn't think it was going to be heavy. It was a tiny little box.
Uh-huh.
It wasn't a tiny little box. Wow. It was really heavy.
So imagine you have right here in the center I to the power of 24. Okay, right? What is this? So what you need to do, the way to simplify this is, you want to get, this is what you're going to be using. You're going to use the fact that I squared equals minus 1, right? This is what you're going to use. Okay, let's make it as a little cloud here. Okay, so what you need to do, you need to make this into I squared somehow. So what you do, divide 24 by 2, it's 12, right? So it's going to be, you make this into I squared, the whole thing to the power of 12. So your goal is to represent this I to the 24th as I squared to the power of 12, or whatever the power, as long as they multiply, right, 24. Okay. So then, I squared is what? minus
Negative
1,
1.
right there. So hold on, let's write the white parentheses. Hold on. So I squared is negative 1. So technically we have negative 1 to the power of 12, which is what? What would be negative 1 to the power of 12?
Is it? Wouldn't it be 1?
It is just 1, right? Positive 1. So the answer is that I to the 24th is 1.
What the heck?
Okay, well, this is this one. So let's do another one. Let's do I to the power of 25th. What would this be now? Okay. So now I'll do a few first and then you can do some. So notice the next one is an odd power, right?
Yeah.
So you cannot really split it by 2. So what you're going to do, you're going to make this into one even power and one extra I there. You see, because you can 25, you can split it into 24 plus 1, right? This technically is a 1 right there. Oh, the 1 is 1.
Okay.
1. So then I'm going to deal with the 24 the same way I dealt with above. So this is going to be I squared to the power of 12 times I, right? I still have this lonely I there. And then we found out that I squared to the power of 12 is just 1. So the whole thing is just 1 times I or just I. All right.
What happened to the 12?
Because it takes,
1.
yeah, 12 is 1.
So then it's I1.
Yeah, 1 I or just I.
Yeah.
Yeah, the 1 is an inch. Okay. Let's do another one. Let's do I to the 26th. So you're like, okay. 26 is an even number. Yeah, so make it into I squared 13. So then the I squared is minus 1. So technically we have minus 1 to 13th. So what is minus 1 to the power of 13?
Is it negative 1?
That's correct. It's negative 1. So see, now it's negative 1. Okay. Let's do another one. I to the 27th. Okay, let's get blue. See, they're not repeating. First one is 1, I minus 1. Let's do I 27. Can you predict what would it be?
You will do the I26 times
No,
I1.
yeah, 20, that's correct. 26, 1 times 1. That's right. Then split the 26. So this is a fun game, right? And then what would this whole thing be?
1.
No, it's minus I.
Minus.
Because remember, I squared is minus 1 to the power of 13 is still minus 1.
Oh, squared.
And then the I is I, so you have minus I. So you see, they look different things. This is 1, this is 1, this is I, this is minus 1, this is minus.
I? It's such a weird.
From imaginary.
Oh.
See. I know. This is, I had the shirt. Oh, what was my shirt? My shirt was saying, like, this is my shirt. If you remember it, but it says
Yeah.
minus 1 here. I love man. This is how it's written.
Oh.
See?
Oh.
Because square root of minus 1 is I. Get it? Okay. I think you're in a better shape today than last time, so it's good. You're getting those. Okay. So I'll give you one, you do it. How about, let me hide it and you do it. Make it black. So you tell me what is.
Oh, I thought we were doing those.
No, you're doing one by yourself. So what is I to the power of 365? So see if you can apply the rules and tell me. Well, so what difference does it make? It's just a number. We know how to do them. So do it. Do the
I
steps.
don't know how to break this down.
Oh, use your calculator if you need. So first, so look at the steps we did there.
Yeah.
What is the first? So first, actually, what is it if the exponent is odd or if it's even?
It's odd.
Okay, so do what we did when it was odd.
You break it down.
Yeah.
So it'll be 364
Yeah.
times I.
Yeah. And then what?
Ooh.
So what is it?
So what do you do with the 364? Do you
tell
break
me.
it in half?
Yes, break it in half.
So 182.
Okay, yes, and then what?
So 5 squared.
Yes.
182.
Yeah.
Times I.
So what would this be?
-1.
That's right.
Whatever, 2 by this one. 182.
Yeah.
Times I.
So what would this be? Now look if it's even or odd. The exponent was even. So you have -1 to the even exponent, which is what?
-1 to the even exponent.
Is what?
1.
Yeah, this one, because 182 is even. So anything multiplying, if you multiply it by itself even number of times, right?
Mm-hmm.
If it's a negative, it just becomes a positive,
Yeah.
you know.
So it's just 1
I.
I.
Or just, yeah, and when you
Oh my
don't write I,
gosh.
just I. Right? So you have to apply the rules, okay, and just get it. It's nothing super hard.
It's not hard. Just I feel like the big number was like scaring me.
Yeah, but that's why we did it. So it's not in the numbers. It's just okay. So moving on.
Moving on.
Oh, this is hard a little bit, a little hard, but you're a daughter of the Most High King, and you can do all things to Christ who strengthens you.
You're texting.
No, I'm not texting. I'm just checking.
What are you texting? That was good.
It was good. Okay. Yeah, I was just randomly clicking. Okay, mouse. It was good. Okay. So the next thing is the conjugates. Do you remember those? We did them in a few chapters ago.
I think we did them last chapter, didn't we?
Yeah, we did them, the conjugates. So again, now what you do with the conjugates, they were for last time what we did. What am I doing? Okay. What we did last time, the conjugates were for radicals. It was like, what was it? 2 plus square root of 2, right? And the conjugate to this one was 2 minus square root of 2. This is what we did last time. Okay. The difference was between the conjugate was just the minus and the plus in the middle, right? Okay. This thing here was the difference. Now, and so when you multiply them, do you remember the red ones, when you multiply them, what do they equal to? 2 plus square root of 2, 2 minus square root of 2, what does this equal to? Which formula was that?
The 8.
Yeah.
A minus.
A plus B, A minus B, what does this equal to?
2?
It was A plus B, A minus B is difference of squares. And if Kason was here, he was going to probably say it was A squared minus B squared. Or at least we hope he would have said that. So Kason, if you're watching, you can go on the dashboard and write this formula. Write the difference of squares formula for extra credit.
Oh, extra credit.
If you're watching. Okay, if you do this, I'm not going to say because then Mariano will probably text you. So no. So for extra credit. Because I was saying, if he does this, I'll give you extra credit too, but then you go tell him now to do it. So no.
I won't tell him.
Let's see if you do it. Okay, Kason, it's on you.
I don't have any. I can't. I don't know anywhere.
You can always find everybody on Populi. Yes, there is a search thing. You just click and put their name and everything.
Did it gives you information?
Yeah, phone number, email, picture.
That's not good.
Why? If they want to contact you, they're your friends. Okay. So after all this argument, so it's 8 plus B, A minus B. So what it means? So it's going to be 2 squared. I'll just write it as squares. 2 squared minus square root of 2 squared, right? I just applied the difference of squares formula. Right, Mariana? You have to learn this formula. You have to. So this is the thing. You need it. Memorize it. So when somebody wakes you up in the middle of the night and asks you, what is the difference of squares formula? You need to tell them.
A plus B, A minus B equals A squared plus B squared.
It's minus B squared. It's a difference of
Oh,
squares.
minus.
Okay. So let's finish. So this is 4 And square root of 2 squared is just 2, right? Because square cancels. So this is 2. The whole thing is 2. I just continue at the top. So you can see that when you multiply the two conjugates, the radical disappeared, right? This is a property of multiplying conjugates. So let's do the same thing with the complex numbers. So now we have a plus bi times a minus bi, right? Okay. Let's just apply the formula, right? So what it is going to be a squared minus, I'm going to put this in parentheses, bi the whole thing squared, right? Is the first thing squared minus the second thing squared. I just apply the formula. So then let's a little bit manipulate the second thing. So it's going to be minus b squared times I squared. All right, you need to make sure each one of those is square, the b and the I, right? Okay. So then let's apply what we know about I squared, that I squared is negative. So the whole thing is a squared minus b squared times negative 1, right? And if you do the negative 1 times the minus over there, is going to be, yeah,
A squared plus
b squared, yes. So for the, when you have the complex numbers, the formula always going to come out as that, right here. But this time it's going to be plus. This is only because of the I. And what you notice, there is no I anymore. So these are just real numbers, right? So multiplying the conjugates removes the imaginary part.
Interesting.
It is interesting. The conjugates, when you multiply them, they get rid of the weird stuff. The radicals, the imaginary stuff.
I guess the conjugates are good for us then.
Yeah. I always think of them as brothers or some kind of twins, but one of them is black, the other is white. I don't know. Or one is tall, the other is short. They're like different. Okay. So here, the first one is super easy. It says, find the, hold on.
Ooh, I don't like those A's.
Where is he? A's. Oh, you're A's. So find the conjugate. Only to do the they're asking you what's the conjugate. You don't need to do anything. So what is the conjugate of 4 plus 3i? Going to be 4 minus 3i. This is the conjugate, right? It's the same number with minus instead of plus in the middle. So next one, find the, write it down, okay.
Find conjugate
of the number. This is all we're doing, just finding the conjugate of the number. So,
man, I wonder what the heck I put on the test, the placing test when I saw this.
I don't know what you're putting. It's okay, place to right. It means okay, we got it. You see, now if you take it, it would be interesting what you get. Okay, so.
I'd probably still get a bad grade.
No, we should try. We see. Okay, so the next one, again, you just need to change only the middle. So it's going to be minus 6. The 6 would stay, and negative 6. Yeah, plus 9. The only thing we change is the one in between. Okay. The last one, so let's see. Let's get green. That's correct. Because you can imagine that it was 0 plus I, right? You
So
can,
could it be I squared?
no, don't square it. No. Conjugate, you're writing the, oh yeah, but just write the conjugate. You're just writing what the conjugate is 0 minus I, or just minus I. I wrote the 0 just for you, just minus I, right? But the reason is because it was 0 plus I, so now it's 0 minus I.
Okay.
So here, the conjugate of I is minus I. Okay. Moving on, now we need to apply them. It will be done. So we use those. So this is how we are going to use them. I'll start with the second one because actually the second one is a little easier, I think. Simplify. So hold on, I'll write them down. Are they from the book? Oh, I think it's from the book for minus 3. Okay. It's not from the book, but I'll write another. So hold on, don't write it yet.
Oh, don't write it?
No, because divide. Yeah, write this, but then we are going to write it out ourselves. Okay, and I don't know what the number was. I'm getting the one from the book. So we're getting okay, I'm making it up actually. 3 divided by 4 plus 3i, right? And it says divide and simplify as it is. So I should have not put this cosine there. So what it is, it's like the, remember the radical expressions which are like 1 over 2 plus square root of 2. Remember we had to rationalize the denominator last time. What did we do to rationalize it? You can say Mariana has not practiced, but
Is it that you trying to divide the reciprocal?
not the conjugate. Remember the conjugates?
To minus, yeah.
The both, right? This is how we did it there. So now we're going to look here. So when you're multiplying, when you have denominator with the imaginary number, you want to get rid of the imaginary number in the denominator. The same thing when you have here rational, irrational numbers or radicals in general, your goal was to get rid of the radicals in the denominator. Remember the good manners? Okay. So here now we're going to multiply by the conjugate.
So 4 minus 3i
Yes.
on both sides.
Yes.
And then that
So
cancels.
now nothing cancels. You need to now see what happens, but doesn't cancel because you just wrote it down. Right. What cancels? Nothing cancels. But no, I mean it's going to cancel eventually. The not going to cancel, but it's going to disappear. The I. Okay.
12 minus 9i.
Yeah, on top is like that. You're right. 12 minus 9i. Okay. The denominator. So now we need to distribute. You see those kind of distribute? No, not distribute. The difference of squares formula. Don't distribute. So what was the difference of squares? You see, when you multiply two conjugate, what was happening? Is the first thing squared, right? It was actually a squared plus b squared. Do you remember?
Oh, yeah. It's right here.
Yeah, so then the b is just the 3. It's going to be 4 squared plus 3 squared, really. If you remember the formula. If not, you can distribute.
Yeah, because for the radicals, it was minus.
Yeah,
right?
yeah, but this is
Minus
plus. Yeah,
is
because the plus is because of the I squared. Yeah. And so you see, we don't have any more imaginary number in the denominator, so it's going to be 16 plus 9, which is 25 on the bottom. This is just that, so you're done. Oh wait, not done. What did they, so one thing they usually say divide, simplify, and write your result as a plus bi. They want your result to look like that, all right? So in order to do this, I'm going to take this up, make circle with in pink. Oh, it wasn't pink, it's white again. I'm going to take this, I want to make this to look like a plus bi. So what we're going to do, we're going to split it. It's going to be 12 over 25 minus 9 over 25i. See? So what you do, you just take, this whole thing and make a real part, imaginary part. And you see like the split. We'll do one more and then we'll be done because we're getting...
that's the answer?
Yes. We're getting overboard a little bit. So let's see. Yeah, here is the answer. What's the last thing?
Wait, why is it 13?
This is a different problem.
Oh, that's right.
We're not going to do this. Okay. So right here, let's do one more. I want to do one more with those when they're multiplied. So let's get I'll get it from the book here. I'll do, if somebody is using the book by any chance, on page 765, we're going to divide the Olive Garden 31, which is, yeah, I wonder what Lilia is doing right now. Remember Lilia? She's the one who was the reason for us to come up with the Olive Garden thing. because she used to work at Olive Garden. Okay. So the yellow is your problem. This is 2 of z, and it says divide and simplify to the form a plus bi. So our goal is to make this into a plus bi. Okay. So what are we going to do? First step. Mariana, what we're doing? What are we doing?
First step is
Mhm.
we need the conjugate.
That's right. Multiply by the conjugate of the denominator.
1 plus 3i.
That's correct. Okay, so now we need to deal with the numerator and denominator. I said, let's do the denominator first. So what is 1 minus 3 and 1 plus 3i? What was the formula? A minus
Squared
1 squared, which is
plus
1, plus
3i
3 squared. No. Remember,
no,
when
I
you do
know,
the
I
plus,
know.
the I disappear. So it's just 3 squared, which is 9.
Oh, yeah.
So the whole thing is 10, technically.
Okay, hold on.
10.
So 1 squared plus 3 squared. 1
Yeah.
plus 9.
Yeah, so 10. So now we need to multiply the top, and you have to distribute. So let me kind of give you parentheses.
Oh, man.
I know, but keep going. You can do this. 6, 18. Now we need to simplify this.
Already got a space.
6.
29.
That's correct. How about the last thing now? What is this?
Minus 6?
That's correct, minus 6. Oh, look, the 6s would cancel. Oh, how nice.
Oh, how nice.
Yeah, this was, God gave us a
Thank you,
gift. So it became 20i over 10. So now actually we can divide the 20 and the 10. All right. Just going to be 2i. Yeah, no. The 20 and the 10 divided by 20 divided by 10 is 2. What are you doing?
Oh, it's just 2i.
Yeah. And
wait, but that's not in the form of a.
it is in the form, just it is in the form because yeah, a is just 0. This is the form 0 plus 2i, but you don't write the 0. So this is in the form. But
this
just
one wasn't too bad.
no, we got lucky. But this is how I do those. Okay. So everybody watching, this concludes our today's lesson, and we'll stop recording.